So, hi everybody. I will be presenting the project I did with Makan, Bo, and Amit. We call it Birdify. It's just an app that helps you find which bird you saw by the picture. Why is it needed? Well, first, okay, I'll use this. Why is it needed? First, for fun. Okay? Lots of people like bird watching, like taking pictures of birds, looking for interesting species, and they would be happy to know easily what's the bird they saw. And also for the normal people who don't know much about birds, but sometimes go to a hike and want to know what they do. So there are actually few apps that do it for plants. I guess it's more popular. But there are also other applications that can be more important, I would say. So first is tracking bird migration. That's something I wanted to pursue, but I was looking for data and actually contacted all these bird watching stations in Israel, and it was quite hard to get them. And even if I got some pictures, it would not have been labeled and would be a bit out of scope of this project. And there's also recognizing harmful birds for agriculture purposes and monitoring birds surrounding the airport that can actually harm and be quite dangerous. So we're looking for data, obviously first in Kaggle, and well, we were successful, found 4 different data sets that could be suitable. We started researching them and eventually got to the one we see here. We picked this one because of a few reasons. First, it had quite a lot of high quality pictures. Second, all the pictures were the same size. It was already resized for the right size you can work with. And there was some activity on this data set, but not too much. You see here now there are 30 kernels. Back when we started, it was 17. So there is some information, but not too much that everything was done. Like those with 1,000 kernels, you can't do anything new. So we started researching. We looked a little bit at the pictures. Does anyone know this bird? Does anyone see this bird? It's very popular in Peru. You've been there, you probably, right? We did some more data exploration. Each picture is 224 by 224 pixels and 3 channels, which makes it easier because also most models work on this. There are about 30,000 images, 200 species, as you already saw. And what you didn't see yet is that the minimum number of pictures per species was 87. So, well, I had no sense back then if that's enough, but it's not like there were no species with like 10 pictures that can really work. So it seemed like a good and robust data set. We also made some simple dimensionality reduction to be able to see the pictures on its space. And we actually saw by these some interesting problem that we were afraid to encounter, which is the background. If you see those pictures, all those pictures are in blue background, sky and water, and all these are green, and this is black. So, that's one problem we were thinking that we encountered. can be a problem, like we saw in the interpretability class, I think. Another problem is that for some bird species, male and female don't look the same. So you can see here this African firefinch and American firefinch and cinnamon teal. They look quite different, and it could be a problem.
What's the name?
You're ready to the left one?
Is that brilliant? This is the male.
Is the animal?
In most species, the male is the natural unlike human. Yeah, you can see it like with human makeup. This is actually wrong because we were supposed to classify the same class. I don't know if you can. Another one is that all the pictures were resized. So if the picture was like stretched, like if you took a picture on a phone like that, then you squish it and it looks like this, or maybe not all the pictures were good quality, but actually most of them were. And I will talk about it just a few sentences in the end, and we'll see if we could solve these problems. So we started with basic modeling. I wanted to do some basic modeling to experience in all these random forests, decision trees, stuff like that. And I started only in 20 species because the data, even though it's not too many pictures, it's quite heavy because each picture has a lot of pixels and 3 channels and stuff like that. And actually, even these 20 species, most of the models took a few minutes. And those are the simple ones, right? And so I started with 20, and we got really bad accuracy. You can see here that's nothing. The only one that gave some nice result was actually the simple logistic regression. But even that's 60%. That's not something that we can work, and we actually needed to scale it to 200 species, which is probably harder task. So we figured out quite fast that we'll have to do it in CNN, because CNN can also catch the proximity between the different pixels, which the simple models don't really catch. And we started with building a very simple model, CNN, with one convolutional layer and one fully connected layer. We did it only on 5 species, and it should have popped up. We got only 58% accuracy, which is quite bad. Obviously, it's quite bad. We designed it, and we didn't know back then. I mean, it was just after the class we had. We didn't really know how to design. Even if you want to design, it's a lot of work to do and a lot of experimentation. And training is hard because you have lots of things to train. So we decided to do some transfer learning and look for a pre-trained network that can help us solve it. The first one that we took was the ResNet that we study on. The ResNet was published in 2015 by this group. For mine, I have to show it. I'll be here for now. And what they saw is that back then, if you remember, there was only the VGG networks. It was sort of like brute force, like let's make more and more convolution layers, and it will be better. But they saw, and you can see here, that if you get deeper, you don't necessarily get better. Okay? They tested 20 layers network with 56 layers, and the 20 was actually had a lower training rate. And the reason is the vanishing gradient. Like the deeper levels did not catch the information anymore. So what they did is develop this skip connection that sort of make a bypass for every few layers, and perform better, and you can build deeper networks, and we got to 50 ResNet. The Keras ResNet is 50 layers. It's more different. So what we did is took it as a black box. We added another layer, fully connected layer with 20 species. We said it worked only 20 at this time, and trained only these way, so it wasn't so heavy, so hard to train. And we got great accuracy, 97%. So back then, I saw it, I said, okay, we're done. All we need is train it on 200 species, and we're over. But then, we tried it on 30, and accuracy actually dropped. I'm not sure, I can't really say why, but we tried to solve it by doing either train other levels, like going to other levels, release the ways for training, and get it better. This could be quite a lot of work, because we need trial and error, and we don't really know which ones we prefer to train. And another way is to search for other ones. Also, you got we found the MobileNet. MobileNet is a bit newer, I think, published in 2019, and introduced Delphi separable solutions. And the idea is that it's very light. I mean, what they try to do is to keep high accuracy of. I think it was trained on the ImageNet, but with less weight, lighter computation power as you need. And actually, it's called MobileNet because it was you can train it on a mobile phone. So skip next. The reason we chose it is because we saw a kernel that does something similar to what we want. In large animals, so we thought maybe it would work, and it worked. Gave us 95% accuracy on the 200 classes, and that's pretty much it. Remember, we had two problems that I talked about. We actually checked that, and this network didn't resolve them. It still had problems with the female pictures. It still had problems with stretch or compact. We didn't check all the issues and cases, but that's the 5% error that we had. And lastly, we did some Flask and implemented it, and we had some web browser for it, and now you done.
Hi guys, welcome to our amazing app, Verified AI. Find your bird. You can see that we have two options here. You can either select an image file, or you can take a webcam picture. So let's use this picture. So either you can take a picture of the national bird of Israel, or awful quality. Wow, amazingly we got the accurate page in Wikipedia and 100% confidence that it is indeed a. So let's try another one, which is the core favorite bird, the ostrich. Wow, that's just incredible.
So yeah, that's it. Is there time for questions?
The images that you showed, are they like from the test set, or did you can go like randomly on the internet and choose an image?
What do you mean? The images that
If I put bird in,
no. So what Matan showed here is just pictures that he found online. Well, you can find the Hupu. Well, you could find, but he didn't go and take the picture.
that's
And then,